Hello, 7th grade science students. Mr. Core here. I'm going to take you through the Earthquake and Volcano Lab and focus our talk to review for the quiz tomorrow on earthquakes and volcanoes. And we are going to feature two videos here, this one being more centered around earthquakes, the next one being more centered around volcanoes. So to begin, let's just do a quick review about plate tectonics. Divergent, convergent, and transform are your three types of boundaries. And all three of them have the capability of producing an earthquake. Albeit, convergent and transform are where your more devastating, larger magnitude earthquakes would take place. Now, out of those three, however, only your divergent and convergent have the ability to produce volcanoes. Again, your convergent being your larger type volcanic stratovolcanoes, composite type that can form large mountain ranges, as well as volcanic mountain ranges. Divergent can still form volcanoes, but they're not of explosives. Plus, they're mainly 2 miles underneath the ocean surface, so we don't see those as much. But in Iceland, there are volcanoes that can be dangerous that sit on a ridge-type divergent boundary. So, again, all three of them can cause earthquakes, but only your convergent and divergent can cause earthquakes and volcanoes. And we'll continue more. Now, to start, we're going to focus on a little bit related to earthquakes. And this is showing you an example of how a convergent boundary, when it's grinding down inside of there, it's building up pressure, it's causing melting, and then when that pressure snaps, it can cause an earthquake. And that earthquake, if it's out in the ocean, can push the land up and cause a tsunami. So lots of different things can occur. But again, your main reason is, these convergent boundaries are your most dangerous types of boundaries related to volcanoes and earthquakes.
So what we need to understand about earthquakes is that they are a massive transfer of energy. And if you look here, I'm going to show you an example of that through this tuning fork, okay? So, if I hit the tuning fork, you can see it vibrates and makes noise. That's a transfer of energy. And you may not think so, but if I take this and hit it and place it in the water, you're going to see how vibration can cause a transfer of energy. So what you saw there was the energy of the vibration of the tuning fork, which is a sound wave, transferred to the water and causing the water to move. Seismic waves or earthquake waves are an example of this because they transfer their energy through the movement of the Earth's materials, rock, dirt that are inside the Earth and on the surface of the Earth. So we can see that one more time. Get close, please. Get close to the water.